All right, thank you all for coming to my talk. Today we're going to be talking about a front-end developer's guide to Web3. A little bit of a agenda, I guess. I like always sharing this out so you get an idea of what you're going to be learning today. We're going to go over like a high-level kind of overview of smart contracts and like what you kind of need to know about them as a front-end developer. We're going to talk about connecting to smart contracts, connecting to the blockchain, talking about wallets, RPC endpoints. Talk about how we actually, do fetching of like data. It's not always like, using the fetch or Axios. We're gonna look at some dope tools that you can use to build in Web3 from a front-end perspective as well. So real quick, hi, I'm Rahat. I'm a developer advocate over at Polygon. Previously been a front-end engineer, Solidity engineer, sort of an indie hacker / like Web3 enthusiast, always working and tinkering on like different little tiny projects. Some places you can find me, Twitter, LinkedIn. Some of the code examples that I'm going to be sharing are all available on my GitHub as well. So the company I work for, Polygon, we have several different offerings for scaling on top of the Ethereum blockchain. The most popular one that many people probably know about is our proof-of-stake blockchain, which is currently a carbon negative blockchain, and we're striving to be completely climate positive over the next year. So over to what we're going to be talking about, smart contracts. This is the code of the blockchain. It's what we deploy onto the blockchain, what our decentralized applications are actually running on top of. What do you need to know about smart contracts? This is mainly from like I said, a high-level overview. Some of the languages you use to write smart contracts include Solidity. Solidity is the main thing we're going to be focusing on kind of today. That's what a lot of EVM-compatible blockchains are going to be using. EVM-compatible means that there's like a one-to-one kind of like relationship between being able to deploy this on Ethereum versus another blockchain. Polygon is a good example of one of those. Some other languages that smart contracts can be written in are Rust, Viper, and Go. As far as deployment goes, how do we get a smart contract onto the blockchain? Solidity is a very high-level language, and that needs to be compiled down into what's called bytecode or machine-readable code. Once you have that bytecode, you need to pay some gas fees. What are gas fees? Very similar to when those prices skyrocket at the pump, those prices can skyrocket on the blockchain. A little story I like to share. When I was first learning how to develop and like build smart contracts was about this time last year, I guess. It was kind of like at the height of the hype of like several different NFT projects coming out. And I had a very poorly written smart contract, had a lot of nonsense in it. I was trying to get it out onto like the Ethereum mainnet. And I think I had to pay, or I didn't end up paying it, but it was like $1,000 to actually get it onto production, which is wild. But that's the way gas prices can go. And that's why there's other solutions, kind of like what we're doing at Polygon to make sure, this becomes more accessible to a wider variety of people. Some things you need for deployment is like a deployment script. These can be, written through tools like Hardhat and Truffle, which are environments, sort of like essentially like tools for creating environments for like testing, deploying smart contracts, getting them out onto the main net. And the last thing you need access to is an Ethereum node, such as just a computer running the Ethereum blockchain. You can run your own if you have the hardware to do so. You can use a public RPC endpoint, or you can use services like Alchemy and Infura, which can help you with accessing these RPC endpoints using some type of API key. What we're really going to be focusing on now are just like interactions. How do we interact from our front end with the blockchain? We can do it through a wallet or through an RPC or remote procedure call. So you see two pictures on here. First one is a wallet. This is a hardware wallet. Generally, you'll probably see something like, what's popular is something like this, which is a MetaMask wallet. I don't actually have that much ETH. This is on a test network. I really wish I had that much ETH, but I don't. So there's that. But this is what's called like it's a MetaMask wallet. It is a browser extension for connecting to the blockchain. You might have heard, I think Nader mentioned it before, wallets are wallets should not be named wallets. They're not wallets. They don't contain any money whatsoever. What they do contain is a key value pair for accessing the blockchain. First is like a public key, which kind of like identifies your wallet on the blockchain. Next is a private key, which allows you access to the blockchain, which like helps you like get, pointing to the values of like whatever crypto or NFT that you own on the blockchain. So if we connect through a user's wallet to the blockchain, this is great for use cases where you're wanting to like mint an NFT, swap some coins, anything that requires user consent to do, you want to connect through a wallet. Next is an RPC endpoint. I couldn't find a very good picture to represent an RPC endpoint, so I have this matrixy looking thing. But essentially, it's an endpoint that's given to us by a node provider. Like I mentioned before, a couple of those are Alchemy and Infura. They're great for decentralized applications that don't need user consent to do something. Essentially, if you're just displaying some data, you want to create a block explorer like Polygonscan or Etherscan. Maybe you want to display just like some alpha for some NFTs that are coming out, just like some information about that. All that can be done using an RPC endpoint. So we're going to break down and look at some code. First, how do we interact with the blockchain wallet edition? So what you'll see up here is a handle, I call it a handle wallet connect function. It's an asynchronous function, and you would add this to like an on-click listener to a button. First thing I'm doing is pulling out the Ethereum object out of a window. You're probably just like, hold on. There is no Ethereum object in the window, but there is, as long as you have a Chrome extension or some type of extension like MetaMask, which will inject the Ethereum object into your window, into your browser. So when I pull the Ethereum window out, I get a bunch of information regarding the user. So I'm using a library here called Ethers. Ethers just gives us some really cool providers that allow us to access the user's information, access the blockchain through that user's wallet. So we provide them that Ethereum object to the provider. And then the next thing we can do is just like request access to that user's account. That's this like provider.send line. And then what I'm doing here is just like getting some information about their address. So let's see what that looks like in action. So you'll see here I have this like connect your wallet to view your address. I hit connect wallet, MetaMask automatically pops up. I hit connect and I'm connected to the address. That's like a very, very basic way of connecting to a user's wallet and just starting to interact with them on that level. Now, another common connect wallet pattern will be taking all of that code I just showed you before and wrapping it inside of a use effect. Please don't do this. I tweeted this out a couple days ago. This is a huge pet peeve of mine. If I ever land on a decentralized application page and the first thing that happens is that my MetaMask pops up and tells me to connect something, I will refuse to use your application. No one should ever use an application like that. This is a very big security risk. And the main thing that you're really doing here is you're removing the ability for a user to give consent to actually connect to your application. And that is huge, super important. And a lot of people might say, oh no, you can go into your MetaMask and just like, not verify the transaction. Please stop. No. Nothing associated to my financials, nothing associated to my address should ever pop up at any point in time unless I specifically initiate that transaction itself. And a good way to think about it is just like, you don't want to go to a website and the first thing that happens is the video starts playing, music starts playing. You gotta, Google will penalize you for that. Hopefully someday people will be penalized for this too. Now, kind of going beyond Connect Wallet and sign in, one thing I'd like to mention is like sign in with Ethereum. This whole wallet connection feature is just like one of my favorite things about Web3 because it gives us a true single sign-on experience. You can take your wallet wherever you want, and that is your identity on the blockchain. You don't need to create a new email account. You don't need to have like Facebook or Google manage your OAuth account or anything like that. Everything is tied to this key value pair. Just go in, authorize your wallet, create a new account on wherever you want. There's a whole bunch of other things that kind of go on in the back end. That's a whole other talk we won't go into, but definitely recommend looking into sign with Ethereum. This is kind of like the basis of like at least the first level of how it works. So we talked about interacting with the blockchain through a wallet. How do we interact with the blockchain through an RPC endpoint? Pretty similar. I have up here just some boilerplate code, creating a provider where rather than connecting to the Ethereum object in the window, I'm connecting to some RPC endpoint. And this is really good for getting information about the blockchain and just like creating those like alpha sites for understanding transactions, understanding some of the cool stuff that are going on right now. I was playing around with some of this a little bit before, where I was like getting kind of like the last 10 blocks on the blockchain, displaying some information about them. And this was just like a little demo that I did of like the last 10 blocks on Polygon, including like their block number, et cetera, et cetera. But this is kind of like the basis of how things like Etherscan, Polygonscan, et cetera, are built. And you want to, if you ever wanted to like go and create something just displaying trends, just displaying some data, this is a good way to do that. Cool. So we talked about connecting to the blockchain. How do we fetch data? How do we actually interact with a smart contract, right? Well, we need a map. Solidity code, like I mentioned before, it gets compiled down to bytecode. But there needs to be a way for us to traverse that bytecode. There needs to be a way for JavaScript to be like, okay, how do I actually work with this? Rather than using Axios or using like a fetch call or something like that, we need to use something called an ABI, or an application binary interface. And this is just a fancy word for a gigantic JSON file. That's all it is. This JSON file contains information about how to, like the type of functions that are defined, the type of inputs that are needed for this, and just like different state variables and things like that that are part of this smart contract. So how does that work? How do we put all of that together now? If we're doing this from like a React sort of perspective, first thing, import your dependencies. Ethers is the library that I mentioned before. And you'll see here I'm importing this ABI from lugia.json. This is a smart contract I wrote when I was first learning, and essentially it's just a Pokemon battle between a Charizard and a Lugia. And you'll get to see that in a second. So this is like the connect to contract kind of boilerplate code. And essentially you just give the contract address. So similar to how you have an address for your wallet on the blockchain, there's an address for every contract that is deployed on the blockchain. Everything that exists has an address, has something that's tied to it. So you make sure you get that address, you import your ABI, which is that JSON file, you instantiate that provider again, give the window.ethereum values, and the rest of it is just like some more boilerplate code for actually getting this contract connection set up. But now what all that does is give us access to the functions that are on that smart contract. One of those that I wrote is this like attack function where Charizard starts attacking Lugia, and at the end you get some value of like the current HP coming back. And you'll notice here a couple things. So first, I do like this, awaiting that vital contract.attack to actually have that attack function run. That is an asynchronous call. But I also need to, once again, wait for that actual call to finish going through. This was done kind of like on the Ethereum blockchain. Things are kind of slow. While that call is like running and happening, things need to be verified on the blockchain. There needs to be like, if there's some gas fees associated, that needs to be paid. This kind of takes care of waiting for all of that stuff. And then the last two lines is just me kind of displaying the current HP. One thing to kind of note, and you'll see that in the demo that's coming up right now, is that this attack function costs money. Why does it cost money? Because it actually changes the current HP of the two Pokemon that are battling. And whenever you change any data that's on the blockchain, whenever you add any data, anything that requires you to do some type of writing, some type of mutation, instead of just reading, you're going to need to pay some level of gas fee. So this is a quick demo of Charizard attacking Lugia. Rather than attack, I did like a use flamethrower thing. My MetaMask pops up, and you'll see that there's like an estimated gas fee. This is on a test network, so gas fees are pretty low. And then, voila, Charizard is now attacking because I paid the necessary gas fee for this to happen. And cool, that gets updated. So what are the main things to take away from this talk, to remember? Front-end development in Web3 remains more or less the same. You're still manipulating the DOM. You're still building, components if you're in the React space. All of that's the same. The shift in mindset comes from like doing like HTTP requests with like fetch and Axios to instead using ABI code to call your smart contracts, to do those reading, functionality, to do that writing functionality. Everything happens through this ABI code. And the last thing to remember, mutations cost money. So this is something to keep in mind for your users. One thing that I've been kind of exploring in this space is doing something like what's called gasless meta transactions, which is like paying for fees for onboarding your users. So if you want to get people kind of like into your application quickly, you can actually pay for the gas and fees for them. That's a whole other conversation too, but these are like the different things that we're exploring in this space to make sure that people can actually start using Web3. So some front-end development tools I would love to point out that have helped me, that I've been using a lot. Ethers was one of the ones that I kind of showcased during this talk. Ethers is really good for like connecting to the to wallets, RPC providers, connecting to the blockchain, doing transactions on smart contracts. An alternative to Ethers is the Web3 JS library. Kind of like does similar stuff, just a different set of APIs for that. One of my favorite ones, though, is the WAGMI library. And this is actually built around Ethers. And what this does is it makes a lot of like the functionality that you would get from Ethers much easier to use, especially in like a React application, because you get a whole bunch of React hooks for connecting to wallets, signing messages, calling smart contracts, et cetera. And probably one of the, if not the best Web3 library currently in existence based on the documentation alone. Another thing I'd like to shout out is Web3 UI. This was actually built, is being built by Developer DAO. Was started by one of the Developer DAO members, Daiwat. He started this where, this is a library that gives you like different React components for doing things like connecting to wallet, connecting smart contracts pretty quickly as well. You definitely want to look at things like block explorers, like Polygonscan, Etherscan, for looking at these transactions. You can even like try out different functionalities of a smart contract directly from Etherscan or Polygonscan before you actually import them into your front end. Another really awesome tool that I wanted to shout out is Laika. It's kind of like a postman for Web3, where you get to like actually create different requests, connect to a smart contract, similar to what Etherscan does, but in like a local development kind of phase. So thank you for coming to my talk. Again, Rahat. These are a couple places you can find me. I'm going to be dropping links to the resources of the stuff that I mentioned in Discord under the channel that has my name on it. So if you want to go in, dive in a little bit deeper, and look at some of that stuff, that'll be available there. Thank you.
Thanks so much.